Hello, welcome to our video source inspection today. Today is Tuesday, January 30th, 2024. My name is Daniel Mullany, and behind the camera again we have Nico Greiner. And today we are here to film video source inspections of a new Sitek high-profile spin rinse dryer. Our customer is located here in the United States, and their PO number ends in 925653. I will go ahead and get the process started and then discuss the system as we go. So here we have our customer's high-profile 8-inch substrates. This chamber we're actually loaded up with some dummy substrates to mock up the weight. And in our bottom chamber, we have our customer's actual substrates that were sent in for processing in demo in the spin rinse dryer, along with their actual cassette. The cassette is the same as the ones we're using in the top chamber, which is high-profile 8-inch from Integris and A192-80M. Okay? So stepping to the back of the system, I am able to also identify our system serial number, which is SRD-01590. And now I'm going to take a look at our drain boxes and the overall drain out through our floor here. Everything's looking great during the rinse process. I can also turn on and turn off our DI water recirculation feature for both the top and the bottom chamber to validate that that's working properly. Okay, both chambers are looking good there, and there are no leaks on the back of the system. You'll also see the EMO on the front of the system. We have another EMO location on the back of the tool, which allows us to shut down the system from either the front or the back, depending on where an operator or any employee might be in the event that you do need to use the EMO. Okay, so what we've done is we've already completed the rinse and purge cycle on our top chamber. We are now working through purge on the bottom chamber and have now progressed to dry 1. So the typical spin rinse dry process that you're going to use on a rinser dryer is going to involve 4 steps. First, you're going to rinse at a low RPM, somewhere between 300 and 600 for 1 to 2 minutes. Then you're going to purge for 10 seconds as you ramp up your speed to your high RPM step. We then have dry 1, which is our high RPM step. In our case, we're running at 1800, and we have turned on all of the heaters for the system. What we're doing is we're warming up the chamber while also spinning as fast as we consider to be a safe range to sling the majority of water off of the substrates and prepare ourselves for the final step, which is dry 2. Dry 2 is our last step, where we're going to ramp down our RPM to somewhere around 500 or 600, and we're going to stay there for about 5 minutes. At this point, you're going to see inside the chamber that a lot of the water has already started to dry or evaporate up. We can see that the majority of the large water pieces have already slung off of the cassette substrates and rotor, and now we're going to let the heating elements of the system complete the drying process in order to result in a nice uniform dry. This process that I just described has been developed by Semi-Tool originally years ago and has been used over the years to provide the best drying process for your SRD and your product. Okay, I'm going to take a look into the chamber from both sides right now. The top chamber is already ramped down to our lower RPM of 500. Everything's looking good. As I described before, I can see that the majority of those large water bits have already slung off and now are evaporating off the surface of the bowl. And when I come to our bottom chamber, I see the same results. So right now, everything is looking like a normal drying process for the spin rinse dryer. One step that I don't think I clarified quite exactly when I described them is our purge step. So that purge step, which comes right after rinse, is going to be used while we ramp up to the high RPM, and we're going to actually purge our DI manifold of any remaining DI water. So we're going to divert that DI, or that N2 flow, goes through the DI manifold. All of that water is going to spurt out of the manifold, so that way, when we are now moving into our drying process, we're not going to pull any water out of the manifold, nor is any of it going to drip out and potentially fall onto our wafer towards the end of the cycle, which would cause some inconsistent drying or water spotting problems. Okay, everything looks good here. So this system is also configured with all of our normal options for a double stack spin rinse dryer. We have our EMO for the emergency off. We have our resistivity probe in order to measure the resistivity set point of the wastewater. You can actually use that probe to program in a set point that your system needs to meet before it'll progress from your rinse step through purge into the dries. We call this the Q-rinse capability, and what you'll do is you'll set a set point, say something at 12 megohm, 15 megohm, or something else, and at the end of your rinse process, your system is going to need to see that you've met that set point before progressing on to the purge and dry steps. If it doesn't meet that set point within your programmed period of time, it'll then complete the drying process, but provide an alarm to the user at the end to let you know that the process was complete. However, resistivity set point was not met, and you need to inspect either your product, your bowl, or your drain box, maybe something else, to help understand what's causing the low resistivity set point from staying throughout the entire rinse process. We also have two more features on here, which includes our anti-static unit, which is going to prevent any static charge from building up in the chamber at the end of the process cycle. This helps with static sensitive devices as well as particle migration from any particles in the room that might attract to your charged cassette. And then we have the feature I mentioned earlier, which is our DI water recirculation that allows you to prevent any stagnant water in your spin rinse dryer system. Essentially, stagnant water can lead to bacteria growth, so we like to keep that flowing. If you have any sort of DI water capacity issues in your building, you can really ramp down that recirc to a small trickle, and it'll still do its job. Or you can even hook this up to a full facility recirculation, so it's continually recircing through your system with your, again, recirc capability, which then can be used in chillers and a variety of other things in your fab. Okay, everything's looking good still. We've got a little over a minute now. Coming back to the sides of the chamber, and now the majority of the water is starting to evaporate out of the bowl. We still do see a few spots on the wall, but that's okay. Even at the end of our process cycle, there's a chance that we're going to see a little bit of DI water still in the process chamber. That's okay. The main part of our process that we want to inspect at the end is making sure that the rotor, cassette, and substrates are completely dry. If there's a few water droplets inside the chamber, that's not really a problem for your processing or for your recipe design, as those water droplets are not transferring in any way to the cassette and substrates. Okay, everything's looking great. We only have about 20 seconds left, so I'll do a quick rundown of some of the features that you'll find in our controller. One of the best parts about our spin rinse dryer, this includes multiple recipes with the ability to modify each step for the controller. It allows you to have a nitrogen purge saver, which is going to turn off nitrogen waste when the system is sitting in idle. It has data logging and SexGem communication capabilities. It has a maintenance mode in order to individually actuate any of the components on the controller. It also has auto cycle capability in order to run automatically in between runs if it's idle for an extended period of time, plus a variety of others that are found in the manual, and you can take a look at those to see how these controller can effectively run our system and provide excellent results for you. All right, I'm coming into the chamber and I can feel the nitrogen purging in nice and hot. I can feel that the cassette is warm and all of our substrates are nice and dry. Same thing with the bottom chamber. I actually see a couple of those droplets that I mentioned earlier. However, when I feel the cassette, it's warm everywhere. And when I'm inspecting our substrates, the entire set of substrates are dry, as well as the cassette, and is the rotor that I see inside the chamber. All right, so I'd like to thank you for taking the time to view our video source inspection for today. Again, my name is Daniel, and this video is filmed for Sitek Process Solutions. If you'd like to learn more about what we do, please take a look at some more of the videos on the YouTube channel, or on our YouTube channel, which is where you're probably at right now, or head to our website at sitekprocess.com. Sitek is spelled S-I-T-E-K. But what we prefer for you to do most is if you have any questions about what we do, just pick up the phone and give us a call, because we'd be happy to talk with you about what you're trying to achieve and how we can help you with your spin rinse drying needs. Our number is 916-797-9000, and to reach me directly, dial extension 2201. Thank you again for your time, and I hope you have a nice day.